In section 11.3, we're going to look at geometric sequences and series. Earlier in chapter 11, we looked at arithmetic sequences and series. Arithmetic sequences were made by adding a number continually. So you'd have this common difference D that continually got added to your sequence to get the next value in your sequence. Well, the geometric sequence is going to be similar, but instead of adding something each time, we're going to be multiplying something each time. This thing that we're going to be multiplying each time to get the next number in our sequence is going to be called a common ratio R. So how can you find the common ratio R if you don't have it? Well, you got to find out what you're multiplying by each time. So you take two side-by-side elements, and what this is saying, to find R, you take two side-by-side elements and take the one that's later in your list. That's the A sub n plus 1. You take the one that's later in the list and divide it by the one that's right before it. And what that will do is it will give you the number that you're multiplying by. And that's your common ratio R. Remember, you do not have a formula sheet on your test, so it is going to be your responsibility to know and understand these formulas. There's another formula here that says if you want to find just the nth term, meaning any term in your geometric sequence, you need a couple of things. You need, first of all, the A sub 1, which just like before is your first term in the sequence. Then you need your common ratio, which is R. That's the thing you're multiplying by to get the next element in your sequence. And then you raise the R to the n minus 1, which means if you're looking for, let's say, the 10th element in your sequence, then you're actually going to raise it to the 9th, to one less than that, the 9th. So we're also going to need to know which one we're looking for, which element, and we'll just raise the ratio to one less than whatever element we're actually looking for. Okay, so let's look at an example. In this first one, they want us to find A sub n, which means a generic formula for the nth term, and they also want us to find the A sub 5, which means the 5th term. And they give us the first term, A sub 1 equals 8. And they give us the common ratio R of negative 5. So we know that we're starting with the number 8. And what they're basically saying by telling us that the common ratio R is negative 5 is to get the next term in your sequence, you'd multiply by a negative 5, which means your A2 would be negative 40. And then to get the next term in your sequence, you'd multiply by another negative 5, which would give you that A3 is, let's see, a negative times a negative would actually turn you into a positive 200, and so on and so forth. It would keep on going. So the 5th term in your sequence, the formula says to take your first term, which is 8, and multiply it by the common ratio R, which is negative 5, and raise it to one less than that. Well, if we're looking for the 5th term, that means we're actually going to raise it to one less than that, which is 4. So be careful. Order of operations is going to make you do the exponent first. So you'll have to do the negative 5 to the 4th first, which is 625. Then we can multiply it by the 8, the first term 8, which gives us 5,000. That is the value for our A sub 5, our 5th term in the sequence. A general 5th term would have us saying, okay, well, general terms are you always take your first term, which is 8, times your common ratio, which we said is negative 5, and we're looking for just a regular nth term, right? So remember that we do 1 minus that, so minusing 1 from the n would get us n minus 1, and we can just leave it just like that. I know it's not pretty, but that is our final answer for what it would look like for an equation for a geometric sequence.